Okay. Good morning, honorable person here. I am Dr. Rangarajan, Professor Computer Science and Engineering from the College of Weltech Polytech, Dr. Rangarajan, Dr. Samantala Engineering College. Today we will discuss about MPI overview and then MPI communication. MPI is nothing but message passing interface. So normally we can transfer the data from one source to destination. Here, how through via the MPI was used inside the OpenMP. Basically, MPI is nothing but message passing interface. This is based upon the functionality. Based upon the functionality, we can transfer the data from source to destination. First of all, MPI is the specification for message passing library that is standard by MPI forum. And then the main vendor for MPI is Intel. And then MPI CX. After that, mainly it is used for distributed shared memory architecture. So basically, all of them know about two different types of architecture is available. One is symmetric, another one is distributed. Symmetric, the main difference between symmetric and then distribution is symmetric, we can share the memory in common way. In the distributed memory architecture, we have the separate memory unit. Especially the MPI is used for distributed shared memory architecture. And then the functionality of that MPI we can extend with C, C++ and then Photon. So how to extend the C++ Photon we will discuss later. These are the list of basic command available in MPI. MPI underscore init and then MPI underscore finalize, MPI underscore communication size and then MPI underscore communication rank and then send command and then receive command. First of all, the init command and then finalize command is used whenever if you want to use the MPI command, we should start with MPI underscore init, and then if you want to close the functionality means using MPI underscore finalize. Between the initialize and then finalize, we can call all the functionality. The main syntax for MPI is here how to use the MPI. It should be used in capital letter MPI underscore and then starting of the first functionality should be capital letter. Rest of the things are small letters. Why? Because it is case sensitive. These are the commands are case sensitive. We can extend it with either high level languages, either C, C++ and then other languages. Then the finalize we can use to end the next step. We can use to end the text. So these are the basic syntax for MPI program. Already all of them know about how to use the C program. In the C program we can we can include with the header files stdio.h and then if you want to use a string means string.h and then if you want to mathematical using math.h. So a lot of header files is available. In this scenario, here we are using MPI program. If you want to include the MPI functionality using the header file of mpi.h. So mpi.h is nothing but message passing interface header file. So we should include the header file of mpi.h. So this is used to use the functionality like initiate command and then finalize command. So already I said if you want to start the MPI program, we can start with the MPI underscore init using the passing the two arguments, argument C and then argument V. Then rest of the functionality of main function. Then if you want to close the MPI function means we can close with MPI underscore finalize. Up to this some basic idea about MPI program. Then communication. In the MPI communication point of view, it will be categorized into two types. One is point-to-point communication, another one is collective communication. The main difference between point-to-point communication and the collective communication is in the point-to-point communication, none of the internal nodes will not involved. Only direct sender and the receiver only involved. So you can transfer the data from sender to receiver directly using two basic commands. That commands are send command and then receive command. And then the collective communication, we can include all the nodes. So first of all, we discuss about what is point-to-point communication. So already I said the point-to-point communication is nothing but between the two processors we can communicate it using two commands, MPI send and then MPI receive. In the source end, we can use the command using MPI send. In the receiver end, using MPI receive command. So one process perform a send operation and the another process perform a matching receiving operation. So one process for send, another process for receive. So in the sender end, we are using a send source and then sending data means. In the receiver end, using receiver source and then receiver data. And then in the point-to-point communication, two different categories available. One is blocking, another one is non-blocking. So mostly all the communications involve the blocking concept only. In the blocking, we can receive only returns after the data has arrived and is ready for use of the program. And then also a blocking send routine returns after it is saved to modify the application before for reuse. In the case of non-blocking, so in the non-blocking, you can send and then receive the routine will return almost immediately and it is unsafe modified to perform. Then collective communication. So in the collective communication, more than one process will involve. Basically, the collective communication involve more than one process. It will be categorized with three types. One is one-to-many communication, many-to-one communication, many-to-many communication. In the first category, one-to-many communication, the example of broadcasting methodology and then scattering methodology. In the many-to-one communication, gathered methodology and then reduced methodology. Many-to-many communication, all reduced methodology and then all gathered methodology. So totally 6 different functionality available inside the collective communication. Then these are the list of basic command used in MPE send. All of them know about packet formatting. So packets is nothing but each and every packet have some parameters. Basically each and every packet have some parameter. In this scenario, MPE send also have 6 parameters. 6 parameters. So through via the program only we can communicate it. In the packet point of view, the packet was transferred inside the data link layer. In this scenario, MPE send have 6 parameters. First one is start. Void start is nothing but what are the message if you want to send. And then integer count is nothing but the number of messages. Then what are the data type used inside your data. Then designation address, tag value, and then what are the communication if you want to involve. So already I said the communication will categorize to 2 types, collective communication and then point-to-point communication. It will be categorized what are the communication if you want to use. So the messages buffer is described by start, count and then data type, and the designation is the rank of the target process, and then tag is the message identification number. Similarly in the receive. So the main difference between receive command and then send command is send command have 6 parameter, receive command have 7 parameter. So that addition parameter is status. Why? Because if you want to send the data from source to destination, definitely source should know about the data is transfer or not. So the status of the data transformation. So it will be, so we can include one of the command as status. Then these are the list of basic collective operator. So already I said in the collective communication have 6 different types of functionalities. The main thing is broadcasting and then reduce. Here I will explain about the syntax for how the broadcasting is involved and then how the reducing is involved. So the collective operations are called by all the process in a communicator. In the MPE broadcast, so if you want to use the broadcast using the keyword of bcast, so MPE underscore bcast, it distributes data from one process to all other process using the communicators. So the syntax for MPE broadcast is MPE underscore bcast of void message, integer count, and then what are the data type if you are used inside your data, and then router root, and then what are the communicator is involved. Then in the MP reduce combines the data from all the processor in the communicator and return it back to only one process. So we have more than one process. That more than one process is compressed to one process using this command. So MP underscore reduce void message, void receive buffer, integer count, MPE data type, MPE operator. What are the operator will involve, root, router, and then what are the communicator. So in many numerical algorithms, send or receive can be replaced by broadcasting or reducing or improving both simplicity and then efficiency. So this methodology is used to communicate between one source to destination through via the more than one nodes. So if you need any queries, mail me rangarajan@wealtechmultitech.org. My contact number is 80561 33788. In next we will discuss about the next version.